Hello, ladies and gentlemen. This is a test video to see how you like this. Maybe if you're still struggling and confused with some certain points that we talked about in class, you can look at the video. I'm going through the notes again, so if you want to see the examples actually worked out instead of just reading your notes, this might be beneficial for you. So we're going to start section 12.3, dividing polynomials, with an example of dividing a polynomial by a monomial. Oops, I have an email. Sorry about that. That's kind of funny. So there's two different ways we can do this. The first way is kind of like using the distributive property in a kind of a backward sense. If we rewrite this example, dividing this polynomial by this monomial of 2x, let's rewrite it as a fraction. Let's have 4x cubed plus 8x to the second plus 10x, and we're dividing this by 2x. Okay, this will be a little bit easier to manipulate. So what we can do is divide each term in our numerator by our denominator of 2x. In other words, I can kind of split apart this fraction like 4x cubed over 2x plus 8x squared over 2x plus 10x over 2x. I'm dividing each term by the denominator. Now the reason why I know these are going to be addition signs is because these are addition signs in my polynomial. If one was subtraction over here, it would also be subtraction over here. Okay? So let's start simplifying. If I divide 4 and 2, I end up with 2. And x cubed divided by x, I have a like base and I'm dividing, so I subtract exponents. I assume these all have an exponent of 1. So 3 minus 1 is 2, so this is x to the second. For my second term, 8 divided by 2 is going to be 4. And x to the second divided by x to the first, subtracting exponents, is just x to the first, or simply x. And your last term, 10 divided by 2 is 5, and x divided by x will actually cancel, so you're just left with 5. So that's our final result. Okay, so this is the first way you can do it. You break it apart piece by piece, write it as a fraction, and you subtract your exponents like usual. So that's the first way. The second method is going to be a little bit more beneficial because when we divide by binomials, this is the same method we'll use. So we're going to write it using a different notation for division, which you've done in years past. If we're going to divide our polynomial of 4x cubed plus 8x squared plus 10x, we're going to divide this by 2x. So that's the symbol that we're used to working with back in elementary school, middle school, when we're doing long division. So what we'll do is see, starting with my 4x cubed, how many times does 2x go into 4x cubed? Well, let's break this apart and kind of reword it a bit differently. If we take our 4 and divide by 2, it goes in there 2 times. If we take x cubed and divide by x to the first, again, we have x to the second. Okay? We have x cubed divided by x to the first, we subtract exponents and end up with x to the second. Move on to our second term. We'll do 8 divided by our 2, so 8 divided by our 2, which gives us 4, and again that's a plus because we have a plus underneath it. And x squared divided by x to the first, well, we just subtract the exponents, so we just have x to the first, or simply x. And lastly, 10x divided by 2x, 10 divided by 2 is 5, and x divided by x will cancel, so we still end up with the same answer doing it this way. I know you all are probably going to prefer the first way, but I want to show you the second way because the second way is important for when we divide by binomials. Okay? So that's your first example. If you're still writing this, you can pause it. Otherwise, I'm going to change the page in 5, 4, 3, 2, 1. All right, here I want you to pause the video and try working it out yourself. So pause it right here, and then I will work through it, and you can check your answer with what I do. So go ahead and take a second to pause it. Okay, so I'm going to do the first way for the first one and the second way for the second one. So if I have 6x cubed plus 3x squared minus 12x, I'm dividing by 3x. I'm just going to divide each term by 3x. Like the last time, you can break these apart into separate fractions, or you can do some mental math and leave it as the same fraction. So if I have 6 divided by 3, that's 2. And x cubed divided by x to the first is x to the second. So there's my first one. I have an addition sign that I bring down. If I have 3x to the second, well, 3 divided by 3 is going to be 1, so I don't need to put it, it's an assumed 1 in front. And x squared divided by x to the first is simply x. My last term, I have a minus sign that I'm going to bring down. And negative 12 divided by 3 is going to be a negative 4. And then x divided by x will cancel, so there's my correct answer. You can check that with what you just worked out on your own. Secondly, I'm going to divide by 4y. And my polynomial is 12y to the fourth minus 16y to the third plus 20y squared. So again, I'll do my division. 12 divided by 4 is 3, and I place it up top. Y to the fourth divided by y to the first. We subtract exponents is y to the third. I have a negative 16 divided by positive 4, which is negative 4. So I am looking at my signs still. This would be slightly different if I were dividing by a negative 4, because a negative divided by a negative would give me a positive up top, but that's for a different example. So we'll have a negative 4, y to the third divided by y to the first is y to the second. And then positive 20 divided by positive 4 is positive 5. And y to the second divided by y to the first is simply y to the first. And there's your correct answer. You can check that with what you just worked out on your own. Okay, you can pause it here if you want to, or rewind if you want to look through the example again. Okay. Let's try, though, now dividing by a binomial, which is slightly different. So this one is easiest if we just do the notation involved with this symbol instead of the fraction. So my divisor is x minus 1, and I have x squared plus 2x minus 3 for my polynomial. So we're going to divide a polynomial by a binomial this time. What you're going to do is mainly look at the x that's in front here. Okay? We're going to start with our first term, x squared. Well, how many times does x go into x squared? Or in other words, what is x squared divided by x to the first? Well, we just subtract our exponents. We know that x squared divided by x to the first is simply x to the first. In this case, though, since our answer, it goes in x times, we're going to place that up here because we're going to keep the notation, the x's above the x's, the constants above the constants. We're going to keep them in that sort of alignment, okay? Like terms above like terms. So x goes into x squared x times. So x times x is x squared. And negative 1 times x is negative 1x. So we line up our like terms. Okay, this is using our long division like we've done before with numbers. And then at this point, I'll subtract them just like we do when we have numbers. These cancel. And 2x minus 1x is simply x. My next step is to bring down my negative 3. Okay? Now we're going to look in and say, how many times, oops, I made a mistake. Did anybody see it? Of course, it wouldn't be a lesson with Mr. Fillmore without making a mistake. If I have 2x, and I'm subtracting negative 1x, that gives me a positive 3x. Right? If we're subtracting negative 1, so we're subtracting negative 1x. For subtracting a negative is the same as adding. So 2x plus 1x is 3x. That's my fault. So we brought down our 3. Now we want to look and say, how many times can x minus 1 go into 3x minus 3? All right, again, we mainly deal with looking at the x. So how many times can x go into 3x? Or in other words, what is our 3x divided by x? Well, we know that's going to be 3. 3x divided by x, the x's cancel, we're left with 3. In other words, x goes into 3x 3 times. So it goes in 3 times. And x times 3 is 3x. And our negative 1 times 3 is negative 3. Again, I'm subtracting. Well, if I subtract these, both of these are going to cancel, so I don't have any remainder. So my answer is going to be simply x plus 3. If you wanted to check this, you would say that my x plus 3 times my divisor of x minus 1 should give me my polynomial, x squared plus 2x minus 3. And if you ended up foiling our two binomials here, you would end up with x squared plus 2x minus 3, and they would be equal, so your answer would check out. Okay? If you need to pause it here, pause it to review. Otherwise, you can rewind and look through it, or you can move on to the next one, which I'm going to show you. Let's do another divisor that's a binomial. So we have 2x minus 3, and our polynomial is 2x squared plus 11x minus 9. So again, we look at our x's in the front here mainly, and we say we're looking at our first term of 2x squared. Well, 2x squared divided by 2x is going to simply be x, and if you need help working that out, we already did that in class, so that's been worked out for us. 2x squared minus 2x is simply going to be x, but again, we put our x up here, so it's directly above like terms. And 2x over here times x is 2x squared, and our minus 3 times x is going to be minus 3x, and we're subtracting these. When we're subtracting these, our 2x's to the second are going to cancel, and then 11x minus negative 3x is really 11x plus 3x, which is going to be 14x. Then we bring down our minus 9. All right, so the first piece is done. Now we're looking at our 14x. How many times does 2x go into 14x? Or in other words, what's 14x divided by 2x? And that's going to give us an answer of 7. So 7 times our 2x is 14x, and our 7 times our minus 3 is minus 21. We'll subtract these cancel. Negative 9 minus negative 21 is really 9 plus 21. Negative 9 plus 21, which is going to give us an answer of 12. Uh-oh, we can't bring anything else down, so we have a remainder here. If we have a remainder, we don't just say remainder 12 like you might have done in middle school. We don't continually add terms like when we put a decimal and add zeros in long division in middle school. All we do is we say this is plus 12, and we just put our divisor below it. 2x minus 3, and that's going to be our final answer. As goofy as it looks. So there's example number 3. Let's do one or two more. We'll do these practice ones. We should have done them in class. If we didn't cover them in class, we'll review this on Monday before we start reviewing the finals. And let's do one where we actually have to rewrite it first. So let's say, in this case, we want to order it so that our exponents decrease from left to right, or it's in standard form. So for our divisor, instead of 2 plus y, we're going to write it as y plus 2, so our constants at the end. And then our polynomial, we're going to put our largest exponent first, so y to the second, then 5y, and then our constant last, just reordering it. And then we'll do our division again. So looking at our y squared and our y squared divided by y is simply going to be y, and we put that up here because we put it over like terms. Our y times y is y to the second, and our y times our 2 is 2y. We subtract these will cancel, and let me do that in a different color. We'll end up with 5 minus 2 is 3y, and we'll bring down our 4. Now we look and say how many times does y in our divisor go into 3y? Well, it goes in there 3 times, so that's a plus 3. Y times 3 is 3y, and 2 times 3 is 6. We're going to subtract these will cancel. 4 minus 6 is negative 2, so we have a remainder of negative 2. So we write that as a minus 2 over our divisor, y plus 2. There's our final answer. Again, you can check, like usual, by foiling. Again, you can pause it here if you have any questions. You can rewind it. Otherwise, I'm going to move on to one final example. Sometimes you may have to insert a missing term. Okay? And here's what I mean by that. Our divisor, first of all, is negative 1 plus 2m. Let's rewrite that so our constant's last. So it's 2m and then our minus 1. Let's say we're dividing by, we have 13 plus 4m squared. I'm going to rewrite that as 4m squared. And then plus 13 with our constant last. We don't have a middle term of m. In this case, we do have to insert an imaginary middle term. We don't have any m's, so we write it as 0 m. Now we can do our long division. Look at our 2m and our 4m to the second. Well, 2m goes into 4m to the second 2m times. If we divided 4m squared by 2m, we'd end up with 2m. So that goes above our imaginary m's down here because we group like terms above each other. So 2m in our up here multiplied by 2m in our divisor will be 4m to the second. And then 2m times negative 1 in our divisor is going to be negative 2m. Uh-oh. Uh-oh. This is good. Not in the middle of my video. Hold on. I will finish this. So we subtract these. 4m squared minus itself will cancel. And then 0 minus negative 2 is really 0 plus 2. So 0m plus 2m, which is 2m. And we bring down our 13. Now we look at our divisor. 2m goes into 2m down here 1 times. This is a plus 1. And 1 times 2m is 2m. And 1 times negative 1 is negative 1. And we subtract these, so these will cancel. 13 minus negative 1 is really 13 plus 1, which is 14. Our remainder is 14. So our remainder up here is 14. We put it over our divisor. 2m minus 1. There's our final answer. 2m plus 1 plus 14 over 2m minus 1. There's ways we could end up simplifying this, but that's more of an Algebra 2 topic that we kind of ran out of time for this year. This concludes the video. I hope it is helpful. We will see. We will be going over the homework on Monday, so if you have any questions still, we'll review Monday before final review. Adios. Have a nice weekend.